Hey guys, it's Miss Johnson, and I'm here to bring you the second half of section 10.1. We're going to actually carry out a confidence interval for means today. We're actually going to do two of them, so here we go. We'll get started. So let's just revisit those 4 steps that we go through. We want to do state, where we state the parameter that we want and what our confidence level is. So the parameter that you're estimating and what the confidence level is. Then plan. In plan, we're going to identify the appropriate test name or inference method, and then we're also going to check the conditions. In the do, if the conditions are met, we're going to perform our calculations. Remember, that means you're finding the t statistic in this case because we're doing means, and then carry that all out and list what the interval actually is. And then in conclude, we want to interpret what our interval means, especially in the context of the problem. So those are our 4 steps. It's been the same 4 steps as chapter 8 and also chapter 9. We're going to do those 4 steps again in 10 and also chapter 11. So here we go. All right, so here's our first question. It says, in the previous section, you learned that about, that number got cut off there, 73%. About 73% of American adults claim to have read a book in the previous 12 months. This was based on a 2016 Pew Research Center study that interviewed a random sample of 1,520 American adults. In the same study also reported that an average number of books read by the members of the sample, including those who reported reading 0 books, was a mean of 12, with a standard deviation of 18. Interesting. So our mean is 12 and our standard deviation is 18 books. It says construct and interpret a 95% confidence interval for the mean number of books read by all Americans in the previous 12 months. And then part B, in 2011, Pew reported that American adults read an average of 14 books in the previous 12 months. Does your interval from part A provide convincing evidence that 2016 mean is different than 14 books? Okay, so we're going to construct a 95% confidence interval for the true mean number of books read by all Americans in the previous 12 months. Here we go. We're going to start with our state. So we want to construct a 95%, there's my level, confidence interval for mean, or for mu, I should say, which is the true mean number of books read by all American adults in the last 12 months. Okay. So then let's go into our plan and check our conditions here. So because we don't know if this is truly normal and we don't know if this is, and we don't know the true population standard deviation, we only have the standard deviation of our sample, we have to do a t-test. So we are going to do, or a t-interval, a 1 sample t-interval for population mean. That's what we're going to calculate. And then let's check our 3 conditions. So random, we have a random sample of 1,520 American adults. 10%, 1,000 and equals 1,520 is less than or equal to 10% of all American adults. We know that to be true. And then the large counts. So this is one, or large sample, they sometimes refer to it as. N is equal to 1,520, which is greater than or equal to 30. So you're good there, okay? So since the sample size is large, we're good to go. All right, there's our state and our plan for that interval. So now let's go on to the calculations. So in the do, I know that my sample mean is 12. So x bar is equal to 12. I also know S of x is equal to 18. Okay, so that's one thing. So if I use technology, now you can use table B if you want, or you can use technology. So if I use technology here, and I'm going to go to inverse T, and remember we're looking at 95%, so that means my tail probability is that 0.025. So 0.025 is my tail probability, and then my degrees of freedom is going to be 1,519. And you can label those. You should, actually. I should be labeling those things. Actually, I'm going to go back and do that. Ignore me. I'm going to erase that and write out what I am putting in. So my tail probability area, I should call it, is the 0.025. And then degrees of freedom are 1,519 for one less than the sample size, which was n. Okay, so now let's go to our calculator. So second distribution, inverse T, for me it's option 4. I've got a tail probability of 0.025. I get degrees of freedom of 1,519. I paste that, and I get a T star of 1.962, we'll call it. There's my T star value. Okay, so now let's actually put it into our confidence interval. So my 95% CI is going to be my sample mean plus or minus my T star value times the sampling standard deviation of 18 divided by the square root of n, 1,520. So let's type all that into our calculator. I'm going to do the whole right-hand side first so that I get that margin of error. So I've got 18 divided by the square root of 1,520. Now notice that only the denominator is under the radical sign this time. That's a little bit different than proportions. So make sure you're typing it into your calculator the right way. So I've got 18 divided by the square root of 1,520, and then I multiply that times the 1.962, and that gives me so I've got 12 plus or minus 0.906. So that 0.906, that's my margin of error right there. So in case you forgot what that value is. So now if I actually do the addition and subtraction, 12 plus my previous answer and 12 minus my previous answer, I end up with a confidence interval of 11.094 up to 12.906. Okay, there's my do statement. So that's the end of the do. Now I have to actually make a conclusion to that. What does that mean? Okay, so now let's do our conclude statement. So I cleared my screen off a little bit and slid my interval up just so I could see what it is as I'm writing this out. So my conclude statement looks like this. We are 95% confident that the interval of 11.094 to 12.906, and we're talking about books. So when we're talking about means here, we need to give it a label. So 11.094 to 12.906 books captures the true population mean number of books that all American adults read. or I should say have read in the previous 12 months. All right. There you have it. Okay, so state plan do conclude. There they all are. All right, now let's talk about in option B, or in part B, it says Pew reported that American adults read an average of 14 books in 2011 in the previous 12 months. Does your interval from part A provide convincing evidence that the 2016 mean is different than 14 books? Explain your answer. So in this case, I would say yes. Yes. The 2016 is mean is different. And that's just simply because 14 is not in our interval at all. So therefore, it's not a plausible value. All right, therefore, that's an F there. It is not a plausible value. All right, okay. Moving on, we're going to do this one more time together, and then we're going to be good with section 10.1. So it says a manufacturer of high-resolution video terminals must control the tension on the mesh of fine wires that lies behind the surface of the viewing screen. Too much tension will tear the mesh, and too little will allow wrinkles. The tension is measured by an electrical device with output readings in millivolts. Some variation is inherent in the production process. Here are the tension readings from a random sample of 20 screens from a single day's production. Construct and interpret a 90% confidence interval for the mean tension mu of all the screens produced on this day. All right, so here we go. First thing, state. Okay, we want to construct, or we will, sometimes they say we will, sometimes they don't even introduce it, they just start off with 90% confidence interval. So 90% confidence interval for mu, the true mean tension of all screens produced on a given day. And we do need to give it a label here because it's a mean, not a proportion. Proportions don't have labels because they're just kind of like percentages, but the mean, it actually correlates to a value. So in millivolts. Okay. So there's our state. Now let's go to plan. So for plan, okay, this is a 1 sample T interval for mean. Okay, and then let's check our conditions. So random, we were told that they were randomly selected. So random sample of 20. Okay, 10%. It is safe to assume that n equaling 20 is less than or equal to 10% of all screens made that day. Okay. And then here's where large counts is going to come into play. So we don't actually have large counts here. So n is equal to 20, which is not greater than or equal to 30. Okay. So, but let's take a look at the graph. So we're going to take a look at the graph of this data, and we're going to determine if our graph looks relatively normal or has any outliers. So here's what I'm going to do. I am going to, because I think it's easier to look at this graph when I put it into my calculator. So I'm going to go through and actually type all of this data into my stat editor. So if you don't remember how to do that, click the stat button on your calculator and click into edit, and then flip back to the table in the previous slide, and we're going to enter in all the data from that table. Okay, so I went ahead and entered all of the data into my list one, and now I'm going to go into my stat plot, and I'm going to turn on, I'm actually going to do a histogram because I think that's going to be the easiest plot for me to do in my calculator. So, because if you do a scatter plot, you need two sets of data. You could do a box and whisker plot as well, or you could do, yeah, I'm going to do a histogram. So a histogram is going to be my option here, and I'm just going to see what happens and see what it looks like. So then I go to zoom and I hit zoom 9, which gives me a graph that looks kind of like this. So I end up with a histogram. Now, you may be better off making a stat or a scatter, no, a dot plot out of these. But this is one way that your calculator can give you a graph. So my histogram looks like this, and then it comes up, and then it goes over, and then it goes peaks one more time, and then there is a break, and then there's one more bar over there, okay? So that's the histogram of the data. And I would say that there is no strong skew. A graph of the data shows no strong skew or outliers. And that's enough for us to continue on. All right. The AP exam tip that we saw yesterday in our notes talked about how if you don't have a graph, you have to create one of some sort. So if I were doing a better job of listing out what this graph is, I would definitely label it. I'd put my intervals down here. Or again, you could just do a dot plot where you've got like the values and then you mark wherever your data falls and go on from there. But draw yourself out the graph somehow, in some way, draw out the graph so that you can show there's no strong skew or outliers. Okay, so now I'm gonna move on to my do steps. So now that I've entered all of my data into that stat editor, I'm actually gonna go to my one variable statistics, and I'm going to calculate out my one variable stats for list one. That's going to be important here because you weren't given the X bar or the S of X value here. So I'm going to do one variable stats on list one, and it tells me that my X bar value or my mean is 306.32, and that my S of X value is 36.21. And remember, we're looking at that S of X value because we're looking at the sampling distribution. We don't want the standard deviation. We want the sampling distribution standard deviation, or the standard error, I guess you could call it. So now the next thing that we have to do is we have to calculate that T star. So I'm looking at a 95% confidence interval. So my T star, I'm going to want inverse T, where my tail probability area is 0.05, because for 90%, I have 10% outside and I cut it in half. So 0.05, and then my degrees of freedom are 19. And if I type that into my calculator, second distribution, do your inverse T, you've got 0.05 for your area, and you've got 19 for your degrees of freedom, and I end up with a T star of 1.729. So that's my T star value. Now I'm going to go ahead and calculate my 95% CI. So that's going to be my mean of 306.32 plus or minus the T star of 1.729. And then it's times the S of X, 36.21, divided by the square root of N, which is 20. I like to calculate that margin of error. You're asked about the margin of error a lot, so I just always find it first. So 36.21 divided by the square root of 20, and then multiply that times the 1.729. So my margin of error, 306.32 plus or minus 13.999 there, 13.999. Or I guess you could call it 14 if you really wanted to. So then I do 306 0.32 minus that margin of error, and 306.32 plus that margin of error. So then my interval goes to, or looks like, 292.32 up to 320.32. All right, there you have it. There's your interval, okay? We got one more step here. I'm gonna go ahead and erase my screen so that I have some room to write my conclude, so hang tight on that. All right, so here's my conclude part. We are 95% confident that the interval from 292.32 to 320.32 millivolts captures the true mean number of millivolts of tension of all screens produced on this day. All right, there you have it. That's the end of our conclude statement. So state, plan, do, conclude, and there we are at the end of our interval. Here's our exam tip. It says if it is not enough just to make a graph of the data on your calculator when assessing normality, you must sketch a graph on your paper to receive credit. You don't have to draw multiple graphs. Any appropriate graph will do. So there you go. That's what I was talking about back when we did this graph. So this was a confidence interval that had a little bit more work to us. We had the actual data, but we didn't have any of the statistics, so we had to find them ourselves. We had to find the mean. We had to find the standard deviation or the standard error because it was not population. We had to find the graph or the picture. We had to construct the graph. So there's just more work to do when you're given the actual data than when they give you the statistics already up front. So keep that in mind. All right, that takes us to the end of section 10.1. Thanks for tuning in, and I will catch you next time.